So to add the logarithm, the property says we have to take these two, all right, and you just take away the addition and you combine the two answers, 8, and you multiply them together. So we get log 7, and 8 times 4 is 32. That's the product property of logarithms. It only works when you have the same base. When you want to subtract logarithms, you have to divide the answers, the numbers. So you do log 5, 100 goes on top, 4 goes on the bottom, and that equals log 5. You just divide the numbers and you get 25. That's using the quotient property of logarithms. Any questions on the... Alright, so the power properties, we're going to take this, you take the exponent right here, and you put it in front of the log. So this becomes 6 log 2 to 32. Let's look at just this part. Pull it over to the side for a second. Log 2 to the 32. And to make it a little easier to understand, let's put an x here. Alright? So if we change this to exponential form, 2 to the x equals 32. Alright? And 2 to the 5th is 32, because 2 times 2 times 2 times 2 times 2 times 2 is 32. So I can take log 2 to the 32. What can I substitute in? Anyone know? What can I substitute in for log 2 to the 32? Log 2 to the 32, we figured out that equals 5. So we take the 6, we take all the log base 2, 32 out, we put a 5 in, and we get 30. First you take the 20, you move it out in front. So it's 20 log 8, base 8 of 4. So 8 to the 2/3 power is what gives us 4. And the reason that is because you take 8 and you do the top part first, which is squaring it. That gives you 64. Then you do the bottom part, which is to the 1/3 power. The 1/3 power is the cube root of 64, and that's where we get 4. Take 20 times 2/3 and get 40 over 3. That's the thing I'm more interested in right now. This is called the power, turn it to my pen, power property of logarithms. Recognize the inverse. This is the log with no number there for the base, so you write base 10 in there to the 0.9 power, and these two basically cancel each other out, and the exponent becomes your answer. So this whole thing is equal to 9, and that's your inverse property of logarithms. like I said before Rebecca started causing problems and I had to stop the recording, it was 0.9. It's very easy. You take this and you divide it, make a division, a fraction. On the top, you're going to put log. Now, 10, I'm not going to write the 10 because understood. 8. And on the bottom, I'm going to write log 32. All right? The 10 is right here and right here, but I just don't write it there because understood that it's there. Now it's not letting me erase it. It's understood it's there, so I don't need to write it there. 0.903 log of 32 is 1.51, and if you divide those, you get about 0.6. I'm going to do log 2. Now you'd have to be pretty smart to get this one. So log 2 to the 8 the top log 2 to the 8th is equal to 2 to some power equals 8. Alright, and this bottom log is 2 to some power equals 5. So these are both equal to my x's. Now I'm going to have different x's. I'm doing these separately. Someone cheated and broke into my iPad. 32. This whole thing is equal to 3. What's the bottom equal to? 5, right? It's 2 to the 5th. So I can replace this with a 3 and I can replace this with a 5. So I get 3 over 5, which equals exactly 0.6.